In this lesson, we look a little more at skewed data, like we did in box and whisker plots. And what I want you to understand is that it's not so much a big deal whether you know what it means to be skewed right or skewed left. But what I do want you to know is that when you have a skewed set of data, it's important to get multiple values to describe it. You can't just use one value and say, oh, the mean is 12 or the mode is 17.5. You have to use multiple ways of describing it so that way you're not being influenced by some skewed information. But there is a chart down here that explains the skews that you might see in a histogram. And remember, a histogram is a bar graph that shows the frequency of data values in different intervals of the same size. So let's move down to example 1. It says to describe the shape of the distribution, and we have a frequency table that shows the number of raffle tickets sold by students, and we have to make a histogram, and then we have to describe the shape. So hopefully making a histogram isn't new to you. Whenever you make a histogram, you just want to make sure that your bars are touching and that your intervals are equal distance. So 1 to 8 is the same amount as 9 to 16, which is the same amount as 17 to 24, etc. So pause the video, draw me a histogram, and make sure that your bars are touching, and then play the video back when you're ready. So here's my histogram. One thing I want to point out is that this bar should not be touching the axis, because remember, this value right here is the number 0. It's 0 on the y-axis, which means it has to be 0 on the x-axis. So you have to leave that space because your graph doesn't start at 0. If your graph did start at 0, then you could use that value, and you could connect it to the axis, but you can't because it starts at 1, so you have to leave a little space. Looking at this graph, it's pretty symmetrical, so let's write symmetrical. So this picture describes exactly what I was referencing earlier. You need different types of information to represent the data depending on how it's skewed, because you can't always use the mean. The mean is a great thing to use if it's symmetrical, because the mean and the median are pretty much the same. When you have a graph that looks like this, we would say this is skewed left because the tail is on the left and the majority of the bars are on the right-hand side. The largest bars are on the right-hand side of the center point. The best one to use is the median, because it's not going to be as affected, if you think about it mathematically, as the mean will be, because the larger values are going to impact the mean more than they would the median. So the median is going to be in the center no matter what your numbers are. So you want to make sure that when you have a skewed group of data, you use the appropriate measurement so that your numbers aren't flawed. All right, let's check out the examples below. We have to just determine whether we would use the mean or the median. So really any type of skew, the answer is always median. So if you look at example A, this is skewed where most of the information is on the left, so we would say the tail is going on the right, so that would be skewed where the tail is, so the skew is towards the right, and we would use the median. In letter B, since it's nice and symmetrical, we would be best served using the average or the mean. When you have a symmetrical distribution, and this is only for symmetrical distributions, but when you have a symmetrical distribution, you can also calculate the standard deviation. When it's skewed, you can't use the standard deviation because there isn't an equal representation on both sides of that center point, so you would make probably a box and whisker plot in order to represent it maybe in a different way. Last one together, a police officer measures the speeds in miles per hour of 30 motorists, and we have the result in a table, so we have to make a histogram using 6 intervals beginning with 31 to 35. So the reason that they tell you how many intervals and what the first one should be is because you can make lots of different sized histograms. You can make one that has, 2 as its range per interval. You could have one that has 10 as its range per interval. So they just want everyone to have the same kind of looking histogram. So that's why they tell you what that first interval should be. So let's set up a frequency table first, because another word for a histogram is a frequency histogram. And so we need the frequencies in order to make the histogram. so we know how high those bars should be. So they tell us the first one is 31 to 35, and that's a distance of 5 speeds. So each interval after that has to be 5 speeds. So the next one is going to be 36 to 40. That's going to be 5 speeds. Then we've got 41 to 45 and 46 to 50. Then we go 51 to 55 and 56 to 60. It doesn't look like there's anything after 60, so that's my highest interval. All right, fill in the frequency table on your own, please. All right, one thing I just want to mention about a frequency table is that you should have numbers, not tally marks. This is why on the test analysis worksheets, I tell you all to use numbers, because numbers are easier to read than tally marks, which you then have to count up. So you can make tally marks on the side, but in the table, you need the numbers. So let's scroll down, use this graph to make our histogram. All right, so one thing I want to again point out is that I had to leave a space over here because my first interval did not start at 0. You can only connect it to the axis when your first interval starts at 0. And if it does start at 0, then you should be connecting it to the axis. Also, I wish I could make my bars a little wider, but I don't have enough to make them all 2. So I have to make them all 1. Ideally, they should be a little wider, but that's just a visual preference that I have. And again, you can make your frequency go by whatever you want. I was able to go by 1s, so I chose to do 1s. All right, now we have to decide which measure best represents it. And again, since it's skewed, again, doesn't matter which way it's skewed. The fact that it's skewed at all means that you have to use the median. Now, again, if you wanted to describe the spread of the data, you would use the box and whisker plot or the 5-number summary, as I said earlier, rather than the standard deviation. We talked about when we learned standard deviation, it's a way of describing the spread of a data, but since this is skewed, you can't use standard deviation at all, so you want to use the 5-number summary. So here's a little question about the histogram. If the speed limit is 45 miles per hour, how would you interpret these results? Are people speeding or are they following the law? So if you look at the frequency table that we made, there's a lot more people going over 45 than 45 or below. So there's clearly a lot of people speeding. All right, if you have any questions, write them down and ask me when you come to class.